Let us study the electronic configuration of elements and how they are placed in the periodic table based on their electronic configurations. As you can see, there is a periodic table. The first 20 boxes of the periodic table have been kept empty. The objective is to place an element correctly in the periodic table. Now let us choose any element. Now this element is having 7 protons, 7 neutrons and 7 electrons. These 7 electrons would be present in shells. You can see I can move the slider over here and I can add the number of shells over here. Right? Now if there are 7 electrons, based on the rules for filling orbitals, 2 in the first shell and 8 in the second shell, that is the maximum capacity of the shells. So if I place 2 orbits, so that is my correct answer. Now the first shell or the K shell can have a maximum of 2 electrons, so I have placed these 2 electrons over here, and the L shell can have maximum of 8 electrons, but since 2 are already there, I will fill the next 5 electrons in the L shell. Right? So this atom with 7 protons and 7 neutrons, 7 electrons is having 2 shells. K shell is having 2 electrons and L shell is having 5 electrons. Now based on this information, if I want to place or if I want to predict the position of this element in the periodic table, the number of shells denotes the period to which this element would be present. Since there are a total of 2 shells, first orbit and second orbit, this element belongs to the second period, and the number of valence electrons decides the group number of this atom. So since there are 5 valence electrons, the element will be present in 5A or group 15 of the modern periodic table. So second period and 15th group decides that this is the correct position of the element, and the element is nitrogen. Let us repeat it for the next element. Here there are total 4 protons, 5 neutrons and 4 electrons. So the number of orbits will be 2. Why? Because 2 in the first shell and 8 in the second shell, right? That is the maximum capacity. Then I have 2 electrons here and 2 electrons here. So total of 4 electrons. So this is my element. It has got 4 protons, 5 neutrons, 2 electrons in the K shell, 2 electrons in the L shell. Since there are 2 orbits, so the period number is is 2. As you can see here, there is a hint. Number of orbits is equal to the period number and number of valence electrons is equal to the group number. So the second period and of course the second group. So this is the correct position of the element, and the element is beryllium. Let's try out with a bigger atom. There are 19 electrons in this case. Okay, so the number of shells, let me put in 4 shells and check. Right, so there are 4 shells in this atom. Out of these 4 shells, first shell has 2 electrons, which is the maximum capacity. Remember here that the maximum capacity is given by the formula 2n squared. So since n is 1 here, 2 multiplied by 1 square, that gives me an answer 2. So that is the maximum capacity of the first shell. Now maximum capacity of the second shell will be 2n squared, so 2 times 2 squared, that gives me an answer 8. So I place the next 8 electrons in the second orbit. So I have placed 2 plus 8, that is total of 10 electrons already. I still have 9 more electrons to place. Now the common mistake as per the 2n square rule is I would try and put in all the 9 electrons, since for the third orbit 2n squared becomes 18. So I would try and put in all the 9 electrons over here, but if I check my answer, it asks me to retry it. Why does it do so? Because the third shell, instead of having 18 electrons, becomes stable at 8 because it achieves a certain stability, and then the last electron goes into the fourth orbit. So this is my correct electronic configuration 2881. Alright, here I can recall all the rules of filling of orbitals. The maximum number of electrons is 2n squared. The electrons are filled in an increasing order of energy. And when 8 electrons are accommodated in the third shell, a certain degree of stability is attained, and therefore the last electron goes into the fourth shell, right? Now I want to place this element in the periodic table. I want to predict its position. So there are 4 shells. It will belong to the fourth period of the periodic table. And since there is only 1 electron in the outermost shell, the group number is 1. This is the correct position, and the element is potassium with atomic number of 19. So by repeating this procedure over and over again, we can place all the first 20 elements in their respective positions in the modern periodic table.